All right, so today we are solving exponential and logarithmic equations. We're going to see how far we get, considering today, again, is a short class. But we're going to use our properties and our laws to solve logarithms as well as exponential equations. Okay? These are your, when we deal with your exponential equations, these are your ones where you cannot write it so that it has the same base like we did before. Okay, these are the ones where we more than likely probably might have to use our calculator to actually solve these out. And honestly, the easiest way to do this is really just through examples, guys. So we're going to be looking at a lot of examples today, and basically working these out. But so then that way you can see how to use properties in the laws of exponents and logarithms to solve these equations. So the first one, solve 5 to the x equals 9. Okay, one of the main ways to solve an exponential equation like this, where you cannot write it so that it has the same base, is to take the log or the natural log of both sides. Okay? So in this problem, we start by taking the log of both sides. This is an equation, so what you do to one side, you do to the other. Alright? And by taking the log of both sides, that allows you to apply your property that says what can you do to your exponent? Move it to the front. So you'll have x times the log of 5 equals the log of 9. And now that x is out of our exponent, what the last thing we have to do is divide. So x equals log 9 divided by log of 5. And we'll go into our calculator, actually type that in, and get a decimal to 3 significant figures. Did you guys get it? There we go. Now real quick, do ln of 9 divided by ln of 5 in your calculator. Get the same thing? As you should. So it doesn't matter whether or not you use logs or natural logs, you're still going to end up with the same answer. Okay? So, to each his own. Questions on this one? Now, the reason why I want to make sure that you guys recognize that natural log and logs are the same thing, and so it doesn't matter whether you take the log of both sides or the natural log of both sides, is because sometimes they might actually ask you to write it in a particular form, like in this example. Solve 6 to the x equals 3 to the x plus 1, giving your answer in the form of ln of a over ln of b, where a and b are integers. So when we solve this equation, we are going to have to use natural log if when we take the log of both sides, because they want us to have it in that form. So we got to make sure that a and b also are integers, so positive and negative whole numbers. Positive ones, since we can't take natural logs of negative numbers. So we start the same way. Okay? We got to get our variables out of the exponent. The only way to do that is to but we have to do what in order to move to the front? We're going to take the log, but in this case we're going to take the natural log of both sides. Then that allows us to bring x to the front here, and then x plus 1 to the front of ln of 3. Now why would I put parentheses around x plus 1? Huh? We brought down the whole thing. And so it's not just x plus 1 and then only 1 is being multiplied by the ln of 3. It's x plus 1. That whole thing is being multiplied by the ln of 3. So what do you think you need to do on the right side? Distribute. So we're going to have the ln of 6, or x ln of 6, then x ln of 3 plus 1 times the ln of 3, which is just ln of 3. Is everyone good up to this point? All right. Now we're trying to solve for x. So what do you think we might need to do? Subtract x ln of 3. Now, I don't want you to think that, oh, well, I have an x ln of 6 on the other side, and when I subtract x ln of 3, that's just going to give me x ln of 3. No, it's literally going to be x ln 6 minus x ln 3. You can't subtract those, okay? You just end up with 1 in natural log. So you want to get all your x's to one side because we are solving for that variable. We learned that a long time ago that when we're solving for a variable, we want to get our variable on one side, everything else on the other. So now that x is on the same side, in two different terms, what do you think we can do from here? Take x out so that we have just the one x. And then our last step will be to divide. So we'll have x equals the ln of 3 divided by the ln of 6 minus the ln of 3. That is our solution, but that's not how they want us to write it. We have to write it so that it's ln of A over ln of B. We only have one ln on the bottom. How do you make that one ln?
Yeah, just cancel that ln of 3 out because there's a negative on the bottom. No.
No, we can't cancel like that. No, not calculator. The bottom, remember your property or your laws of logarithms. Whenever there's a subtraction, you divide. That's why I thought when you go like this, let you divide. But so this turns into the ln of 6 divided by 3 using our law, our quotient law, and then that turns into the ln of 2. And then that is the answer that they want us to write it in. And 3 and 2 are integers. Okay. Let's look at this one. We're going to solve e to the 3x equals 5 to the 1 minus x. And we're giving an exact answer. Now, an exact answer is either a non-terminating decimal that can be converted to a fraction, a whole number, or basically the form that you would get before you actually plug into your calculator to get a decimal. So, suggestions on how we can start? Take the natural log. And I would suggest taking the natural log instead of the regular log because we have an e there. If we take the natural log of both sides, what happens on the left-hand side? ln of e cancels out and 3x comes down. Or if you want to be proper, the 3x comes down first and then ln of e cancels out. Or regardless, it's just going to be 3x. And on the other side, that 1 minus x is going to come down as well. I want you guys to go ahead and finish off this problem. Okay? Finish off this problem. Remember, you want to get your variables on the same side. All right, so let's look at this one. We have 3 times 6 to the x minus 1 equals 2 times 3 to the x plus 2. We're going to give them the form of ln of A over ln of B. A and B are, what does that symbol mean? Integers. Okay, integers. So how can we start this? How do we start any of the other problems? Take the natural log. So let's do that. Let's take the natural log of both sides. If anybody is thinking it, no. You cannot multiply 3 and 6 and 2 and 3 and say this is 18 to the x minus 1 and 6 to the x plus 2. Because only the 6 is being raised to the x minus 1 and only the 3 is being raised to the x plus 2. Not those other numbers. So keep them like that. And then if you're able to recognize that when you have multiplication and a log, what does that mean? Adding. So we can expand this to be the ln of 3 plus the ln of 6 to the x minus 1, and the same thing on this side. Hopefully you guys giving yourself some space. I know I haven't given myself enough space, so I'm going to start writing a little bit smaller. Now what can we do? Bring the exponents down, just like we did before. Yeah, there's an extra ln of 3 and there's an extra ln of 2, but we still do the same process. Bring the exponents down. That's why we took the natural log in the first place. We're trying to get our variable out of the exponent. We just have a few extra numbers. What are we going to do from here? Distribute. This is the longer one, so make sure you don't lose any signs along the way. We're distributing our ln's. And now that we have no exponents, our variables are out of the exponent. Everything's distributed. We're looking at just individual terms. What can we do? Move the x on one side and everything else on the other side. So, you want to move your x's to the left and everything else to the right? Okay, so we're going to have x. I'm going to do this all in one step because I am running out of space. I'm going to have x ln of 6. I'm going to subtract this x ln of 3 over to this side. So I'm going to have a minus x ln of 3. Now on the right hand side, I still have the ln of 2 and the 2 ln of 3. But I'm going to move this ln of 3 over here over by what? I'm going to move it over. Subtract. I'm going to move this ln of 6 over by adding. Okay? Now at this point, it's kind of like, to each his own. If you want to, we can try to condense this this right-hand side, because it is going to have to be ln of one number, not 4 different ln's. How can we condense this? We're going to multiply. Be careful, before we can actually multiply, what do we have to do? We're going to move this 2 to the exponent. So that's going to turn into ln of what? Ln of 3 squared. So I'm going to basically do 2 times 9, right? Okay? 2 times 9. And then I have a minus ln of 3, which means technically what? Minus means what? Dividing. And plus an ln of 6 means multiplying. So that's how this condenses down. I would have, written out, more if I had the space, but I'm trying to condense here, okay? So again, we have to bring the number in the front of the ln up to the exponent, because the only way we can actually multiply or divide is if we just have, regular ln's. So we multiply 2 and 9, divided by 3, and then times 6. And what is that? 36? So my left side is, my right side is the ln of 36. What am I going to do on my left side? Factor out the x And we should recognize that from before, we know we're going to divide, but since we're subtracting, we're technically what? What does subtraction mean if you try and condense this? Dividing. So this turns into the ln of 6 divided by 3, which is what? 2. So technically, we're dividing both sides by the ln of 2. So this turns into our final answer of x equals ln of 36 over the ln of 2. All of that turns into that. This one was probably one of like the more challenging ones because it was so many extra pieces there. Okay? But we still did some similar things from before. We took the natural log of both sides to bring the exponents down, and we applied our laws so that way we could expand that original problem. And then it was just a few algebraic processes. We condensed those logs in that third to last step. We got our final answer. Questions? So there's some log equations. See how many we can get through. I got 4. Let's see if we can get to all 4. We're going to solve log base A of x squared equals log base A of 3x plus 4. Now, one of the things that I do love about logs is that things can cancel out. Okay? Make it a lot easier. If you have one log on the left side and one log on the right side, and they're to the same base, you can cancel them out. Just like how you have exponential functions, they have the same base, you can cancel them out. Same thing, cancel them out and just set this part equal to each other. And hey, what is this? Quadratic. How do you solve quadratic? Which side, left or right? I personally like to keep your x squared positive, so that way when you factor, you have no issues. Still recording this. How's this factor? So we've set both factors equal to 0 and x equals 4 and negative 1. My only issue is that when you're solving logarithmic equations, remember you cannot take the log of what types of numbers? So you got to check them, okay? Plug them in. 4 squared is 16, and then 3 times 4 plus 4. So we're good here. When I plug in negative 1, what's negative 1 squared? Woo, okay. And over here, 3 times negative 1 plus 4. Okay, so this one worked out. They might not always work, both work out. So you always have to check. Questions on that? It's like the easier one. Okay? All right, let's look at this one. We're going to solve the natural log of 12 minus x equals the ln of x plus ln x minus 5. Can we cancel out the ln's and just say it's 12 minus x equals x plus x minus 5? Oh, I'm asking you, Kane. If you say yes, why? If you say no, why? What do you mean? Elaborate more. Well, we canceled out the logs in the last one, right? And remember, before we started canceling, I said the only way that you can cancel is if what? They have the same base and no. You have one log on the left hand side and one log on the right hand side. Do you have that here? You have 2 on the right. But you can write the right hand side as one natural log by, what does plus mean? Multiply. So we're going to multiply multiply x and x minus 5 together so that way we can have one log equaling to another log. And now that we have that, now the natural logs can cancel out, and we have 12 minus x equals x times x minus 5. I'll let you guys solve this out. So again, it's nothing but a quadratic that you can solve. Was it factorable? Yes. What were your two solutions once you factored and solved? And you should have plugged them into check. Did they both work? Careful. The -2 did not work because even though when you plug it in here, yeah, you can multiply them, but the issue is you had a negative log once you plugged in -2. So the only one that worked was 6. Can't take a log or a natural log of a negative number. Like you try to type that into your calculator, you're going to get a big old error message. It's not going to equal the log of the ln 14. Okay? So then we got two more. This one I was saying is like a baby medium one. Okay? We got log base 5 of x minus 2 equals 3. Now, unlike the other two, this one only has one log on one side and a number on the other side. So, another way that you can solve a logarithm is to go ahead and default back to what we first talked about when we talked about logs and evaluating them. How did you evaluate a log a few days ago? And that is doing what? Putting it into the other form, which was called exponential. With these, and I say it's a baby medium one because a lot of times students forget that they can do this. If you have a log on one side and a number on the other side, you can put it in exponential form and still solve it. What's 5 cubed? 125. That equals x minus 2. Add 2. You have 127. Bless you. Question, you plug back in to check. 127 minus 2 is a positive number, so we're good. Questions on that? That's what I said, baby medium. Okay? So let's forget about it. That is an option. Okay? All right. Another baby medium. Log base 2 of x equals log base 2 of x minus 2. All of that equals 3. It's trying to start today. How can we start this one off? We have two logs on the left-hand side and a number on the other side. We could almost do it like the last problem, but we have two logs. We can condense them and write it as 1 by multiplying. And now this allows us to write it how? An exponential, which is finish it out. What were your solutions here? 4 and -2, did they both work? Which one worked? 4. Because when you plug -2 in up here, you get log base 2 of a -2, and that goes against our property that says you cannot take the log of a negative number. Questions? Straight. Last one. This is a higher level one. Okay? And I'm going to work this one out with you. Here we go. We're going to solve log base 4 of x plus log base x of 4 equals 2. And why do you think I say that this is a higher level one? Different bases. Okay? But I can change my base so that they are the same. Using what? Change of base. Which base do you think would be the easiest to change? The second one. So let's take a look at just this part first. Using change of base, what base do I want to have? 4. So using change of base, I'm going to do log base 4 of 4 all over log base 4 of x. Okay, that's using change of base formula from before, what you guys did last couple of days. What's log base 4 of 4? 1. Just like log base 10 of 10 from that one problem from homework. Okay, you got 1 over log base 4 of x. Now I'm going to break down everything else. Now, I know you guys don't like fractions. So how can I get rid of that denominator? What do you think? What? How do you get rid of a denominator? Multiply. The thing is that when you multiply, you have to multiply every single term by log base 4 of x. That means this is going to be multiplied. This is going to be multiplied. And even this is going to be multiplied. Okay? Now log base 4 of x times log base 4 of x is log base 4 of x squared. Here, your log base 4s are going to cancel out and you're just left with a 1. And that's going to equal 2 log base 4 of x. Questions up to this point? Have I lost any? All right. Now, my logs are on opposite sides of each other. I don't want that. Okay? So I need to get them together and I need to get that number by itself. Okay? What can I do? Gonna subtract. Not subtract, but what we can actually do is, this is actually already a quadratic equation. If I bring over the 2 log base 4 of x plus 1, I have what looks almost like a quadratic. What looks like a quadratic, I just have a few logs attached to it. So what I'm going to do is I am going to basically factor this. All right? So we're going to have basically factor it just like how you normally would. Okay? You basically have your x squared, you have a negative 2x plus 1. Okay? What two numbers multiply to give you a positive 1, that adds together to give you a negative 2. Well, that's negative 1 and negative 1. And this time, instead of putting an x and an x to get x squared, you're going to put log base 4 of x and log base 4 of x. Luckily enough, they equal the same thing, so you're only looking at log base 4 of x minus 1 equals 0. Add 1 over, and then writing it in exponential form, you'll have 4 to the first power equals x, and so x is 4. If this if I confused you on this, just shoot me some emails and just let me know, and you guys make sure you complete your homework.